This content is produced by PASS, the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. The slump number is not a strength number. It tells me about the consistency and workability of fresh concrete. The important field decision is how that slump was achieved. Imagine a ready mix truck at the curb. The crew wants a mix that will move easily, fill the forms, and finish without a fight. Somebody reaches for a hose because the load feels stiff. That moment is where supervision matters. Extra water can increase slump, but it also changes the water to cement ratio. An approved water-reducing admixture can also increase slump, but it does so without simply pouring more water into the mix. Those two loads might look equally workable for a few minutes, yet they are not the same concrete. I want you to remember one sentence through this entire lesson. Slump describes fresh concrete behavior. It does not, by itself, prove compressive strength. Cement hardens through hydration, a chemical reaction with water. When more water is added than the approved mix allows, the cement particles are spread farther apart. As unused water leaves the hardened concrete, it can leave capillary voids. The supported practical effect is lower potential strength, greater permeability, and more shrinkage. I do not need to design the mix to supervise this correctly. I do need to protect the approved mix from casual field changes. That is the general B boundary. I coordinate readiness, testing, safe placement, and documentation. The mix design and structural calculations belong to qualified parties. My job is verification, not improvisation. Slump is measured on fresh concrete to describe consistency and workability. A lower slump is generally stiffer. A higher slump is generally more fluid, but the number must always be read together with the approved mix and the method used to reach it. The common mistake is to treat high slump as a synonym for weak concrete. That is too crude. High slump caused by unauthorized water can be damaging because the water-to-cement ratio changes. High slump produced by an approved high-range water-reducing admixture can be entirely consistent with the approved mix. The useful question is not simply, is the slump high? The useful question is, does this measured slump comply with the approved requirements, and was it achieved by an approved method? Slump testing is also not a substitute for strength testing. The slump test evaluates the fresh mix at the time of delivery. Strength specimens, commonly cylinders, are fabricated so the concrete can be tested later for compressive strength at the specified ages. One test speaks to fresh consistency, the other speaks to hardened strength. Keeping those purposes separate prevents a lot of bad field decisions. I also want to separate observation from authority. A finisher can report that the mix feels stiff. A driver can explain what the ticket allows. A special inspector can perform and document required tests. A qualified design professional or other authorized party can determine whether a proposed adjustment remains within the approved mix. The superintendent coordinates that conversation and prevents the pour from moving faster than the decision. The ready mix truck should not become an automatic green light just because it arrived. I treat truck arrival as a quality control gate. I start with the batch ticket and the approved project documents. I verify that the delivered mix identification matches the approved submittal. I check the specified compressive strength, aggregate information, admixtures, and the recorded batching information that the project requires. I also confirm where any permitted field water or admixture adjustment must be recorded and who is authorized to approve it. Some project specifications adopt an industry delivery limit of 90 minutes or 300 drum revolutions, because that limit comes from the adopted project specification rather than a universal California rule. I verify the actual specification, batch ticket, and testing requirements for the job. I do not treat the industry number as automatic state law. Looking at the quality control table, I want you to see 5 separate checkpoints. The batch ticket verifies the identity and recorded delivery information. The slump test checks fresh consistency. The air test checks air content when the project requires it. The temperature check records the concrete temperature before placement. The strength specimens preserve samples for later compressive strength testing. Those checkpoints do different jobs. A clean ticket does not replace a slump test. A passing slump does not replace cylinders. A cylinder set does not excuse an unapproved water addition. Good supervision is not one magic test. It is a chain of matched documents, observations, tests, and approvals. Suppose the ticket calls for the approved structural mix, but the truck carries a different mix identification. Even if the concrete looks workable, I stop the placement decision until the discrepancy is resolved. Appearance cannot repair a paperwork mismatch. The same logic applies when a load is near a project delivery limit, when the measured slump is outside the approved range, or when the temperature does not meet the project requirement. The response is not to guess. The response is to hold, document, and obtain a decision from the proper authority. For concrete that falls within the special inspection requirements, the California Building Code calls for continuous special inspection during the fabrication of strength test specimens, the performance of slump and air content tests, and the determination of concrete temperature before placement. Continuous does not mean an inspector must stare at every square foot of the slab all day. It means the inspector is present continuously while those listed inspection tasks are being performed. The tests cannot be reconstructed after the concrete is already in the forms. A photograph of a finished slab is not a substitute for witnessing the sample, the slump, the air test, the temperature check, and the specimen fabrication at the required time. The special inspection table separates the general rule from a narrow listed exception. When structural concrete is subject to special inspection, the listed testing and specimen tasks require continuous inspection. One California Building Code exception covers continuous footings supporting light frame construction not more than 3 stories, when the specified concrete strength is no more than 2,500 pounds per square inch. That exception should not be stretched into a slogan that residential concrete never needs special inspection. It is a defined condition, not a blanket residential pass. The plans, permit requirements, local enforcement, structural design, and the exact code exception still control. The California Residential Code also lists 2,500 pounds per square inch as the minimum specified compressive strength for basement walls, interior slabs on grade, and foundations not exposed to weather. Conditions exposed to weather can have different requirements. I keep the condition attached to the number so the number does not become misleading. This is a testable concept based on the CSLB study guide because it combines concrete, field inspection performance, coordination, and code compliance. The useful study habit is to ask 2 questions. Does this concrete fall under a special inspection requirement? If an exception is claimed, do all conditions of that exception actually match the project? Now consider the moment when the measured slump is lower than the approved range and the crew wants more workability. The wrong response is to let somebody add water first and ask questions later. I check the ticket, the recorded water allowance, the approved mix information, and the authority for any adjustment. If an approved high-range water-reducing admixture is allowed, it can increase workability without the same direct increase in mixed water. The addition still needs to follow the approved procedure and be documented. The superintendent is not free to invent a dosage or rewrite the mix design at the curb. This is where the phrase "do not water it down" becomes useful, but I use it carefully. The point is not that water can never be added under any circumstance. The point is that field water is a controlled mix change. It must remain within the approved mix limits and follow the required authorization and record keeping. A hose is not a design tool. A good counterfactual is simple. What happens if the crew adds water merely because placement is difficult? The immediate result is easier flow. The next result can be a change water to cement ratio. That can reduce potential strength and increase permeability and shrinkage. The finish may look acceptable on pour day while the mix no longer matches the approved basis. The practical lesson is that short-term convenience can create long-term quality exposure. I also watch the placement plan itself. Poor access, delayed trucks, congested reinforcing steel, or inadequate labor can create pressure to change the concrete. Those are coordination problems. I do not solve a coordination problem by silently changing the material. Before concrete starts moving, the forms, falsework, access, reinforcing steel protection, testing personnel, and placement crew must be ready. Once wet concrete is in motion, every unresolved issue becomes harder and more expensive to correct. California safety orders require falsework and shoring that support concrete to be designed for a minimum total design load of 100 pounds per square foot for combined live and dead loads. The minimum allowance for live load and formwork is 20 pounds per square foot in addition to the concrete weight. The exact design remains the responsibility of qualified parties. The General B responsibility is to make sure the required design, inspection, and certification are in place before loading the system. Employees cannot occupy areas underneath building floor form installations before, during, or after concrete placement unless the forms have been inspected and certified as required. That restriction matters because the load path is active above them. The concrete, forms, workers, equipment, and localized placement loads all act on the supporting system. The placement safety checklist puts the key California rules side by side. Falsework has a minimum total design load. Occupancy beneath floor forms depends on required inspection and certification. Exposed, reinforcing steel ends up to 6 feet above grade need approved protective covers or troughs. Standard caps are not adequate for a fall exposure greater than 7 1/2 feet, unless they are specially designed for that greater impact. Approved impalement covers must withstand a 250-pound bag of dry sand dropped from 10 feet without penetration failure. Nobody rides a concrete bucket, and nobody works beneath a bucket while it is being raised or lowered. I want to pause on the cap rule because it is easy to oversimplify. A cap that helps with a same-level trip hazard is not automatically a fall arrest system. Fall height changes impact energy. California safety orders draw a specific line at 7 1/2 feet for standard caps. Above that exposure, the site needs a specially designed protection system or separate fall protection appropriate to the work. Imagine a crew setting upper wall forms from an elevated platform while standard caps sit on the vertical bars below. The presence of caps does not end the analysis. I compare the possible fall distance with the cap limitation and require the appropriate fall protection before the work continues. That is supervision based on the actual exposure, not on the appearance of compliance. I also treat rebar protection as a pre-pour item, not something to fix after the pump arrives. Exposed ends extending up to 6 feet above grade must be guarded with approved covers or troughs. The cover has to be an actual impalement protection device, not a bright plastic marker that merely makes the steel easier to see. California safety orders prohibit using standard impalement caps for fall protection above the stated height unless the caps are specially designed for the increased impact. They also require the approved cover to survive the specified sandbag drop test. I do not need to perform that test on site. I need to verify that the protection being used is approved for the exposure. During placement, I keep the safety rules as direct as the work. Riding a concrete bucket is prohibited. Employees cannot work under a bucket while it is being elevated or lowered. No hand signal, hard hat, or quick shortcut changes that rule. The clean decision is to keep people out from under the suspended load. For boom pump operations, the delivery hose cannot be used to drag other loads. The same safety orders state that a boom delivery hose is not to be used as an end hose, except for shotcrete or when it is supported by the walking surface. These restrictions keep the placing system used for its intended function, rather than turning the boom and hose into general lifting or dragging equipment. The report also identifies a prohibition on adjusting single-post shores to raise the formwork after concrete placement has begun. That is another reason I want elevations, line, support, and certification settled before the first discharge. Wet concrete is not the time to redesign the support system through field adjustment. Placement quality and placement safety meet at sequencing. The testing team needs access to sample the concrete. The crew needs a workable path that does not force unsafe hose handling. The formwork and shoring need approval before load is applied. The reinforcing steel protection needs to match the fall exposure. The truck sequence needs to support continuous placement without pressuring anyone into an unapproved mix change. The simplest memory rule is ticket, test, then place. Ticket means I confirm the delivered mix and recorded information against the approved documents. Test means the required slump, air content, temperature, and strength specimen work happens at the proper time with the required special inspection. Then place means the site, falsework, rebar protection, access, pump, buckets, and labor are ready before discharge begins. That memory rule also protects the professional boundary. I verify and coordinate. I do not create the mix design. I do not substitute a hose for an approved adjustment. I do not treat a slump result as a strength result. I do not let a claimed exemption float free from its conditions. Based on the published CSLB study outline, concrete, field inspection performance, project coordination, code compliance, and personnel safety all fall within testable material. No one outside the testing authorities knows which questions any individual candidate will receive. The useful preparation is to understand the decision chain well enough to apply it to a new job site scenario. I made an audio practice quiz for this specific episode on concrete slump, testing, and placement. It is audio-based, the questions are read aloud, and you answer by tapping, because I know a lot of this studying happens while driving, working, or moving through the day. Go to the description below this video. You will see a link that says Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about the batch ticket, slump testing, special inspection, water additions, falsework, rebar protection, or placement safety. I read those questions and they helped me see where another explanation may be useful. Subscribe so I can help you stay on track through every episode until you get your license. I know this process asks a lot from someone who is already working, managing jobs, and carrying real responsibilities. I am here to make the study time count.